Hello! Welcome to today's lesson on gravity. We will begin this lesson by understanding that gravity is the natural force that pulls objects with mass towards each other, keeping us grounded on Earth and holding planets in orbit around the Sun. Next, we will learn that the strength of gravity between two objects depends on their masses, with larger masses exerting a stronger gravitational pull. Finally, we will explore how the distance from the center of a gravitational field affects the strength of gravitational force. So far, you have learned about contact and non-contact forces. This foundational knowledge helps us understand that gravity is a non-contact force acting at a distance without any direct physical interaction. Let's get started.
So what exactly is gravity?
Gravity is one of the fundamental forces of nature. It is the attractive force that pulls objects with mass towards each other. Gravity is the reason why we stay anchored to the Earth and why planets, stars, and moons remain in their orbits. The force of gravity is what keeps the moon orbiting around the Earth and the Earth revolving around the Sun. Without gravity, the objects would not have the directional pull needed to keep them in their respective paths.
So, what impacts the strength of gravity?
There are two key factors that impact gravitational strength: mass and distance. The strength of gravity between two objects depends largely on their masses. This means the more massive an object is, the stronger its gravitational pull. For instance, Earth has a significantly larger mass compared to the Moon. As a result, Earth's gravitational pull is much stronger. To illustrate this, when you jump off the ground on Earth, you almost immediately fall back down due to the planet's strong gravitational pull. On the Moon, however, you would experience less gravitational force, enabling you to jump much higher and stay in the air for a longer duration before gently falling back down. You can see this in footage of astronauts on the Moon. The gravitational force experienced from an object decreases as you move further from its center. Each object with mass has a gravitational field, and the closer you are to this center, the stronger the gravitational pull you will feel. For example, the gravitational force that pulls you to the ground is stronger at sea level than if you were on top of a high mountain. As you ascend further into the atmosphere, even into outer space, this gravitational pull becomes progressively weaker. This is why astronauts aboard the International Space Station, ISS, experience microgravity. The ISS orbits the Earth at a significant distance from the surface, where the gravitational pull is weaker than it is at ground level. Astronauts living there practically swim through space to get around. In today's lesson, we learnt that gravity is an attractive force that pulls objects with mass towards each other and keeps celestial bodies in orbit. The strength of this gravitational force depends on the masses of the objects involved, with more massive objects exerting stronger pulls. We also found that the strength of gravity decreases with distance from the object's center, explaining why gravity feels weaker the higher we go. These principles help us understand the fundamental forces at play, both on Earth and in the cosmos. Watch the rest of the GCSE physics course at Sophos Education.